You think knowledge is just more, more information, more science, better instruments, bigger computers. Fine. But why do some questions never get answered? Why do some mysteries survive every breakthrough? And what if the problem isn't that we haven't learned enough, but that reality itself has boundaries built into it? Most people don't ask that. They repeat a comforting idea: give us time, give us technology, we'll figure it out. But that's not an answer. That's a delay. When you really ask what stops knowledge from expanding forever, you find something unsettling. Not a gap in our intelligence, a wall in the universe, a limit so deep that no amount of effort can cross it. Let me show you. Start with something simple. Imagine I hand you a box, perfectly sealed, no windows, no openings, no cracks. Inside the box, I've placed either a candle or nothing, just empty space. Your job is to know which one. You're allowed to do anything except open it. You can shake it, tap it, put it on a scale, press a thermometer against it, hold it to your ear, but you can't look inside. Now stop. Think about this carefully. Can you know what's inside with certainty? Not guess, not assume, know. At first you think yes, because you think knowledge is just cleverness. If you're smart enough, you'll extract the truth. So you start reaching for methods. Wait. If it's a candle, maybe it weighs more. But wait. What if the box itself is heavier than you expected? What if the candle is tiny? What if the candle is there, but the box was built thicker on purpose? Your method collapses into assumptions. Okay, sound, you shake it. If it's empty, maybe you hear nothing. But does hearing nothing mean it's empty? Or does it mean the inside is packed so tightly that nothing can move? Or the candle is fixed in place? Or the walls are padded? Silence isn't evidence. Silence is just silence. So you try temperature. If there's a candle, maybe it's warmer. But if the candle is unlit, it's room temperature. If it's lit, the box changes. And you wouldn't be measuring what was inside. You'd be measuring what your measurement created. And that's the first crack in the dream. To know anything about that box, you have to touch it. You have to interact with it. And the moment you interact with it, you change it. Even if you barely change it, even if you don't notice, even if you swear you were careful. Observation isn't passive, it's physical. It's an interaction between you and the world. And that's the first wall. Knowledge has a cost. Now here's the part people don't like. That box isn't just a box, it's a model of reality. Because every time you measure the universe, you're doing the same thing. You're not reading a label. You're poking something that exists independently of you and demanding an answer. And sometimes reality pushes back. So the limit isn't ignorance. It's the universe charging rent for information. And notice what just happened. The box didn't defeat you because you were stupid. It defeated you because the only way to know is to force a relationship. Weight requires contact, sound requires vibration, temperature requires heat exchange. Every method is a kind of touch. And the more certainty you demand, the more invasive your touch becomes. Because vague knowledge is cheap. You can know something is in there with a gentle tap, but to know it with certainty, to know candle versus empty, you need more interaction, more pressure, more probing, more energy. That's what precision really is, not intelligence, pressure. And that means the universe has a built-in trade. If you want a cleaner answer, you have to pay with a stronger disturbance. If you want to leave reality untouched, you have to accept blur. That's why the idea of perfect, harmless observation is a fantasy. Even your senses don't work without disturbance. Your eyes don't see by looking. They see by being hit. Light strikes your retina, electrons move, chemistry shifts, signals fire. Every fact you've ever learned arrived as an impact. So when people say we'll know everything eventually, they're imagining knowledge as reading. But knowledge isn't reading, knowledge is extraction. And extraction always leaves a mark. That's the first wall in its final form. The universe does not hide truth, it charges for it. And the currency is change. And you can feel that trade in your own hands. A thermometer measures temperature by stealing a little heat. A scale measures weight by resisting motion. A microphone measures sound by being pushed by pressure waves. A camera measures light by absorbing photons. Every instrument is a bargain, a little disturbance in exchange for a little truth. Nothing in the universe gives up information for free. If you want the answer, you have to disturb the thing you're asking. And the sharper the answer you demand, the more forceful the disturbance becomes. That's why perfect observation isn't just hard, it's contradictory. It's asking for an answer with no interaction, a fact with no footprint. And reality doesn't work that way. You don't get truth without contact. You get truth because contact happened. But wait, it gets worse. Because the universe doesn't just hide things behind walls, it hides them behind time. Think about a simple video call. You speak. Your friend hears you a moment later. Not because they're slow, because the signal has to travel. Even across a city, even across an ocean, the message is never instant. You are always talking to the past version of the person you're looking at, only by a fraction of a second. But it's real. Now scale that up, not to oceans, to space. Because the universe runs on the same rule, all knowledge travels as signals, as information. And information has a maximum speed, a cosmic speed limit for news, for cause and effect, for what can influence what. That speed is about 299,792,458 meters per second, roughly 300,000 kilometers per second, light speed. Sounds fast? It is fast, but scale changes what fast means. Light from the sun takes about 8 minutes to reach Earth, so you never see the sun as it is right now. You see the sun as it was 8 minutes ago, always. If the sun vanished this instant, you would still see it shining. You would still feel warmth. For 8 full minutes, because the information hasn't arrived yet. Now widen the lens. The nearest star beyond the sun is over 4 light years away. So when you look at that star, you're seeing a 4-year-old message. If something happened there yesterday, you won't know for years. And when you look at distant galaxies, the delay becomes absurd. Millions of years, hundreds of millions, billions. You are not looking across space. You are looking into history. Every telescope is a time machine, not metaphorically, literally. And that's the second wall. You don't see the universe. You see delayed signals. Now stop, think about what that implies. Certainty is always late. By the time you know something, it's already past. Knowledge is never the present. It's a receipt for what used to be real. So even your cleanest, sharpest truth arrives after the fact. Reality doesn't give you live access. It gives you delayed evidence. And it gets even stranger when you try to fix it, because your brain wants to believe you can recover the present with enough coordination. So imagine you try to build a universal clock. You and a friend are far apart. You agree, when my clock hits 0, I'll send a flash. Your friend says, when I see the flash, I'll send one back. So you start exchanging signals, back and forth, back and forth. And slowly you realize the problem. And this is why the phrase "at the same time" is so slippery. You say 2 events happen simultaneously. But to prove that, you need a signal from each event. And those signals arrive at different moments. So you correct for travel time. Then you notice your correction depends on how fast you're moving. Then you realize even the act of defining simultaneity is tied to your state of motion. So now isn't painted across the universe like a background grid, it's carried by observers. Each observer has a local slice of time that feels like the present, and the universe does not provide a master clock to reconcile them into one global frame. Not because we failed to build it, because there is no physical procedure that produces it. The only way to synchronize clocks is with signals, and signals take time, which means the best you can ever do is a model of simultaneity, a negotiated agreement, a definition, not a direct measurement of a universal now. Because you can't step outside time to compare it. You're trapped inside the flow you're trying to describe. So the present is not something you observe, it's something you define locally. Your now exists where you are. Everything else is inference. Everything else is reconstruction from delayed evidence. That means the universe doesn't just slow your knowledge down, it changes what knowledge means. You don't get a single shared timeline stamped across reality. You get separate bubbles of now, each carried by observers moving through space, and the boundaries between those bubbles aren't psychological, they're physical, built into the speed limit of information itself. So the second wall isn't just delay, it's separation. Reality can be real and still not be present to you. Not because you missed it, because it never arrives as a shared moment in the first place. But wait, it gets stranger, because there are events you will never know. Not later, not eventually, never. Because some information cannot reach you at all. Imagine standing in a field at night. You shout. A second later, you hear an echo from a cliff. That echo is information returning to you. Now imagine the cliff is moving away, farther and farther. Eventually, the echo never returns. Not because your voice stopped being real, not because the cliff stopped existing, but because the distance grows faster than the message can cross it. That's what the expanding universe does. It creates a horizon, not where the universe ends, but where interaction ends, where communication ends, where evidence ends. The observable universe is enormous. The radius is about 46 billion light years. And that number should bother you, because the universe is not 46 billion years old. The number is larger because space expanded while the light was traveling. The light spent time crossing a moving target. So the boundary isn't just a distance. It's a relationship between time, speed, and expansion. It's a limit on reach. Now here's the twist that should make you uncomfortable. There are galaxies we can see today because their light was emitted long ago, back when they were still within reach. But anything they emit now will never arrive. They are already slipping away from causal contact. You can still see their ancient light, while the present version of them becomes unreachable forever. Think about what that means. Reality can be visible and still become unknowable. And this isn't the place you'll reach later. It's a place that will never become evidence. No telescope can fix it. No future technology can fix it. Because it isn't blurry, it's disconnected. And here's the part that feels like science fiction, but isn't. This horizon isn't static, it moves, which means the universe doesn't just contain unreachable regions, it creates them. More and more of reality falls out of contact over time. Imagine a civilization living in a galaxy far away. Right now, you can still see their ancient light, but as expansion accelerates, there comes a moment when the distance grows faster than any new signal can cross. After that moment, their present is sealed off forever. They could build brighter transmitters, they could send 1 billion lasers, they could scream into space with the energy of stars. It wouldn't matter, because the limitation isn't power, it's geometry. The message isn't failing because it's weak, It's failing because the path is closing. The universe is not only hiding information, it's physically preventing new information from being shared. So the horizon is not just a boundary in space, it's a boundary in communication. And it creates a brutal asymmetry. You can still receive their past while their future becomes unreachable. You can still see what they were while what they are becomes forever unknowable. That's not a poetic idea, it's literal, which means the universe contains regions that are real, that may contain matter, energy, planets, even observers, and yet will never leave a trace in your evidence. No light, no signal, no interaction, no causal chain, and that forces a correction to the childish version of science. Science is not learning what exists. Science is learning what can ever be connected to us. Because existence and evidence are not the same thing. The universe can contain truth with no possible witness. Beyond the horizon, the universe can contain truth with no witness. Not because it's hidden, because you can't touch it. Now here's the bridge you need to feel. One horizon cuts you off because you can't reach it. The other cuts you off because reaching it changes it. That's the pattern. Distance can deny access. And even when access exists, access can come with a price. And that leads to the next wall. Not out there, in here. At small scales, the act of knowing becomes a barrier. You think if you had a perfect instrument, you could know everything about a thing. Its exact position, its exact motion, its exact state at the same time, but reality doesn't allow that kind of clean omniscience. Because to measure position, you need resolution. And resolution isn't an idea, it's physical. Here's the rule. If you want to see smaller details, you need shorter wavelength light. Visible light has a wavelength around 500 nanometers, but an atom is about 0.1 nanometers across, thousands of times smaller. To see atomic scales, you need wavelengths thousands of times shorter. That means X-rays. And here's the price. Shorter wavelength means higher energy. Higher energy means impact. The photon doesn't just illuminate the particle, it hits it, it kicks it. So the very act of seeing becomes disturbance. You want sharper position, you pay with a harder kick. You want a gentler touch, you pay with blurrier knowledge. And no amount of engineering can remove that trade, because it isn't about your microscope, it's about what information is. Information comes in physical chunks, physical interactions, and those interactions leave marks. Stop. Think about what that implies. Even the best detectors don't watch particles. They catch impacts. They register disturbances. A measurement is the scar it leaves behind. And you can see this even in the tools we actually build. In your mind, a perfect microscope is just a better lens, more zoom. But in the real world, seeing smaller means using harsher messengers. At some point, your instrument stops being a camera and becomes a hammer. Not intentionally, inevitably. So the fourth wall isn't just a limit on precision, it's a limit on the style of knowledge nature permits. At the bottom, reality is not fully readable, it is only inferable. And inference is the price of physical measurement. So precision is not just a matter of better machines, it's a matter of what nature allows to be sharp at once. And now you can hear the signature idea again. Every bit of certainty costs disturbance. Reality doesn't give free receipts. It charges rent for information. But wait, there's still one wall left. And it's the strangest one because it doesn't come from distance. And it doesn't come from disturbance. It comes from the universe trying to describe itself. You assume that if we just keep learning, eventually we get the final model, a complete picture, a perfect explanation, a theory that contains everything. But here's the hidden trap. Any model you build exists inside the universe. It's made of matter. It occupies space, it consumes time, it cannot contain more information than the thing it describes. So when you hear a grand claim like, "One day we'll know everything," you should translate it. It really means one day we'll extract every answer we can afford, because every answer costs something. It costs time delay, it costs disturbance, it costs causal reach, and some prices are infinite, some prices are simply not payable from inside the universe. Imagine something practical. A hurricane forms over the ocean. You want to predict it perfectly. Every swirl, every shift, every molecule. So you build the best simulation ever made, a planet-sized computer. It measures the atmosphere in complete detail. It calculates every interaction. And then you realize the problem. To simulate the atmosphere molecule by molecule, you need a system that contains at least as much information as the atmosphere, which means your simulator is basically another Earth. And now the prediction isn't simpler than reality. It's reality again. Some systems have no shortcut. The fastest way to know what they will do is to let them do it, because a complete prediction requires a complete reproduction. Now do the same thought experiment with a brain. You want to predict every decision perfectly. So you build a model detailed enough to reproduce every neuron. And the moment you succeed, you see the trap again. You didn't predict the brain, you built another one, a second mind, a second system that must now be simulated too. Stop. That should bother you, because it means some knowledge cannot be compressed. Now push that to the ultimate scale. You want a perfect model of the entire universe, a complete description. But any model inside the universe must itself be part of the universe. So the model must include itself, which increases complexity, which requires a bigger model. And you feel the loop. It's like trying to write a book that contains a complete description of itself, including that sentence, including this sentence, forever. Self-reference isn't just confusing. It creates boundaries, structural boundaries. So even perfect intelligence runs into a shape problem. The universe can't be fully summarized from inside itself. So the dream of total explanation doesn't fail because we're not smart enough. It fails because total is not a stable target. Some questions aren't hard, they're unstable. The moment you demand totality, the system collapses into recursion. And that's the fifth wall. Not technology, not distance, not measurement error, but the architecture of explanation itself. So now we have the pattern. To know is to interact. Interaction disturbs. Information travels at a finite speed. Distance creates horizons. Precision has costs. Self-reference breaks total descriptions. And suddenly the comforting idea fails. The idea that knowledge is just a matter of time. Because some limits don't move when you push. They are built into reality like the shape of a lock. So what does this all mean? Here's the reframe, and this is the sentence you keep. Knowledge isn't just something minds accumulate. It's something the universe permits. Let me say it again. Knowledge isn't just curiosity plus effort. Knowledge is bounded by reality's architecture. Because knowledge is physical, it requires interaction. And interaction is constrained by causality. And causality is constrained by structure. So when you ask, why can't we know everything? The answer isn't human failure. It's the universe enforcing its rules. Now here's the structural reframe, clean and sharp. Knowledge isn't just knowledge. It's the structure of reality pushing back. Sometimes that pushback looks like time delay. Sometimes it looks like uncertainty. Sometimes it looks like a horizon. Sometimes it looks like recursion. But it's the same thing. Reality only allows a certain kind of access. And beyond that access, there isn't more knowledge waiting. There's only silence. Now let's prove this, not with philosophy, with consequences. Look at the sky. When you point a telescope outward, you do not see objects. You see messages, old ones, sometimes ancient ones. Some of what you see no longer exists. Some of what exists you cannot see yet. The sky is not a snapshot. It's a layered archive of time. That's a limit you cannot engineer away. And if you want a proof that this isn't just abstract theory, look at the devices around you. Your phone works because matter has quantized rules. Tiny switches, transistors turn on and off by controlling electrons in structures only a few atoms thick. Lasers work because atoms don't emit light in a continuous smear. They emit it in precise jumps, in packets, with strict allowed energies. Even the best clocks we can build don't keep time by gears or springs. They keep time by counting quantum transitions events so regular that a second becomes an exact number of them. But that precision comes with noise. At small scales, you hit a floor where randomness isn't a bug in the machine. It's part of nature. So engineers don't eliminate uncertainty. They design around it, they average it, they extract patterns from it, which is just another way of saying the universe doesn't give you perfect access. It gives you constraints and then dares you to build anyway. Now look at technology that has to work. Satellites orbit Earth. They carry clocks. Those clocks tick differently than clocks on the ground. And if you don't correct for it, navigation fails. Not by a little, by kilometers. Fast. Without the corrections, GPS drifts by about 10 kilometers per day. Your phone would think you're in the wrong neighborhood, then the wrong city, not because the software is broken, because reality charges interest on time. And then there's the horizon, the hard one, the brutal one. You cannot build an antenna that receives a message that cannot arrive. You cannot build a telescope that sees light that will never reach you. You cannot cross a boundary defined by causality itself. If the universe expands in such a way that some regions can never communicate with you, no cleverness changes that. Because the limitation is not in your device, it's in reality's wiring. So the limit matters, not as pessimism, as clarity. A limit is not a failure. A limit is a feature, a border, a shape. Now here's the meaning. The universe is not obligated to be fully legible. Your intuition built for survival on human scales does not automatically extend to the foundations of existence. You can know an astonishing amount. You can reconstruct the life cycle of stars. You can measure the oldest light in the cosmos. You can build machines that depend on timing differences smaller than anything your body can feel. You can turn invisible laws into technology. This is not a story of ignorance. It's a story of boundaries. And boundaries change the entire emotion of mystery. Because when you know where the boundary is, you stop confusing mystery with temporary ignorance. You stop assuming every unanswered question is waiting for the next breakthrough. Some unanswered questions are permanent features of existence. Not because the universe is hiding, because some things are outside causal contact. Some things cannot be measured without being altered. Some things cannot be fully predicted without being recreated. Some things cannot be fully compressed from inside themselves. And at that point, you understand something rare. To be intelligent isn't to know everything. It's to know where knowing stops, where explanation ends and structure begins, where questions stop being hard and become impossible. Not emotionally impossible, physically, logically, architecturally impossible. Now the last line, the one you leave with. The limit of knowledge is not a tragedy. It's the shape of reality pressing back. You are a thinking organism inside a universe that permits thought, that permits measurement, that permits understanding, but not omniscience. And the fact that we can even map that boundary, the fact that we can stand at the edge of what can be known and recognize it as an edge, that is the miracle. Not comfort, truth.